So let's continue using the die class to talk about classes and objects. So there's one important aspect which we finally need to get to with classes, and that is the idea of accessors and mutators. These are methods specifically designed to return a value which is inside the class or inside the object when you create one. We call that one the accessor. Also, we need to talk about methods that can change the value in a very reasonable, intelligent manner, that can change the value of an attribute within a class. We call that a mutator because it mutates. It makes a change to the I guess the reason or the DNA of the object. So it's the idea of accessors and mutators. We need to talk about those. So if we look at the die class, it really only has one, and that's the face value. We do have the max, which is the max number of sides, but that's just a constant, and it's only used within the class. At no point can we actually change or look at that value if we're using a die object. The only one we can look at is just that face value. So let's just consider face value as being the only attribute, the only variable. That one is referred to as an instance variable because it is dependent on the instance of that class. And an instance of a class we refer to as an object. So every die object will have its own face value, which means that we can change the face value for one die object and there's no influence to another one. So that face value attribute, that integer, is referred to as an instance variable. So previously when we looked at the same level of variable which is outside of the methods for a main method type program, we referred to that as a global variable because all the methods could look at that variable and change it. When it comes to objects, when we start looking at objects and we look at the die class, in this case, all the methods within that object, so within that die object that we have, for example, the roll, the set face value, the get face value, they can all refer back to the same variable. So it looks very similar to a global variable, but in this case, it's called an instance variable, or just calling it an attribute. So we're going to look at how we can actually work with that idea that every die object has its own face value. So if we look at this example, when we created the two die objects in the Snake Eyes program, each object pointed to its own little thing, which was the object itself, which had a face value. So we can look at that in different ways, and one of the things we can use to describe it is this idea of a UML diagram, a Unified Modeling Language diagram, which essentially is this. So if we look at this, this is a breakdown of the Snake Eyes program with relation to the die class. And we can see that the die class also uses java.util.math as also another class. For UML diagrams, I'm going to leave that for the next semester when you take more advanced programming. It's not important for this course. I'm not going to ask you to do any unified modeling, if you will. The only type of diagram I might ask you to create might be something similar to this one, which would be show me the attributes for this object and give me the methods, just a breakdown of the methods, because that is all we really need. Um, but that breakdown right there is very similar to, if you look at this one right here, the die object, that is the same diagram. But this has a proper name to it, the Unified Modeling Language. But I'm not going to ask you for arrows and connect objects together. No, no, no. We're only going to look at this side to say, what is the API? What is the application program interface for this particular object? Is it do we have any attributes here? Do we have any methods? For those of you also looking at this, the minus and the minus symbol usually indicates that it's private, whereas the plus symbol in front indicates that it's public, so that you could see clearly that max and face value are local and only used within the object, within that class definition, and these methods are public. they're available outside. Uh, so that would be the only reason, but I'm not going to ask you specific UML diagram questions. So looking at the accessors and mutators for the die class. So how can we access the face value from the object itself using a method? Also, how can we change it? How can we mutate that value? So this is the concept of accessors and mutators. Now, there is no such thing called an accessor or mutator. It's not a method. You don't give a special name to a method and say accessor or mutator. It's just how you treat these methods. How do you go about actually calling them, and what is the purpose of the method? So essentially, a method that returns a value but makes no change to it is referred to as an accessor. Any method which does make a change to the attribute is referred to as a mutator, and that's just a terminology point of view. These are also known as gets and sets because of the name. So if the method starts with get something, it's usually going to be an accessor. If it starts with set something, it's usually going to be a mutator, which is also why they're known as getters and setters. So if you're looking at a method or a class definition and there's a bunch of methods and they're grouped together and the programmer has written and said, these are my getters and these are my setters, now you know what the getters and setters are. It's the accessors and mutators. The programmer has provided you, as another programmer, they've provided you the ability to get the values back and not change them. So it's a bunch of accessor methods. Also, a bunch of methods which do let you change the attribute or the attributes, and almost always in a secure manner. So you can think of the secure manner as being our um, our set face value. You can only set the face value if it's within the confines of the proper range of face values. So from 1, 2, 3, 5, or 6. Anything outside that range is invalid. So our setter here, our set face value, is ensuring some security. And that's almost why you would have to use these. But we'll go through an example of where we don't actually have any gets and sets and see what the issues could be with that one. So, um, how do we go about doing it? Oop, let's go back to that. How do we go about doing it? Well, let's go back to our code here and take a look at what we've got. So, we've got our face value here. It's our attribute for every object, and it's private, which means you can't access it outside. You can't make any changes to it. We have our constructor. Our constructor sets the face value, and it sets it to 1. This is not a get or set. It's neither an accessor nor a mutator because it doesn't have any control from the outside world. So when you create this object, it just gets a value of 1. So this constructor is not known as an accessor or mutator. It's really just a constructor. If we go down into this role here, the role itself is setting the value, but it is doing it internally. The role method itself doesn't change the value of face value. It doesn't do anything which is being controlled from the outside. It's rolling the die internally. So it's doing exactly what a die roll would be, or a dice roll. But if we look at the set face value, this one is a mutator. And it's even in the comment. This changes the face value. And it's changing it from something which is getting passed in. So this is definitely a mutator. If we look at the accessor makes no change to face value. It's literally just returning the value. And if we look at the toString method, the toString method is returning a representation of the face value. Therefore, really, this is a form of accessor. So it really is a form of accessor. It's not changing the value, but it is getting it back. Now, the one thing it differs from get face value and set face value are using the exact same data type as face value. So if this was returning back a double of some sort, it might still be an accessor, but it really would be a sort of modified accessor because we wouldn't be getting back the exact same data type. There is no requirement for a class to have accessors or mutators. If you think of the string class, With the string class, you can get back a character at a particular position, so using char at. You can also get a string that's within the string, and that's using substring. Uh, those are, in a way, accessors, and you can treat them as such. There are no mutators. You can't change the characters within a string. You can define a brand new string, but that literally is a new string, so it's somewhere else in memory. So the string class really only has accessors, if you will. And you can also ask for the length. You can do a get length, and that'll return back the length. So even the string class has this idea of using these mutators and accessors, although it really doesn't have any mutators. So let's take a look at adding a brand new method, and what we will do is use the idea that we saw, if I can get to it, right here. So each die object has its own face value. Now, we also do a comparison of face values when it comes to the Snake Eyes program. So when we looked at the Snake Eyes program, we saw that we could actually compare the two die together. So in this case, we were looking at getting the face value of the first die, and we got the face value of the second die. We didn't compare them together, but we did compare them against a particular value. So we're using the accessor here to get the face value back. But could we actually do a comparison of the two die together? And for that one, think of the string class with its equals method. So if we wanted to compare two strings together, so let's go ahead and create another string here. So we'll do it die, let's say Juliet. We'll stick on the Shakespeare theme. So we'll create a brand new die. Now we know that the die objects get a value of 1 to begin with. So this is initialized to 1, and so is this one. So without doing anything else to the die objects, we know they have a value of 1. So let's just go ahead and display Juliet as well. And for this one, we are definitely using the toString method here to display both of these. So if we compile this and we run it, what we should see is that Romeo die value has 1, Juliet has a die value of 1 as well. Could we actually ask if the two are equal to each other? So could we ask this question? If die 1 is equal to die 2? And let's display that they are equal. So let's go ahead and compile it, and we have now a problem. So let's see. First of all, I used the wrong name. I'm thinking of the previous Snake Eyes program. So Romeo and Juliet. And let's compile here. And it compiles just fine. Let's see if it runs. Well, clearly they're not equal to each other because we didn't display dice are equal. Let's put an else in there just to make sure that this is clear. That should be a little bit clearer now. So we should see that the die are not equal. But the question is, why aren't the die equal? If they both have a value of 1, shouldn't they be equal to each other? Well, you probably realized when we were talking about objects, we're not actually comparing the values together. What we're actually comparing here, let's move this comment up above. This is actually comparing the memory addresses of each one. Well, that's unfortunate. And this was a warning when we did the strings. even though the string content might be the same as two strings, the memory addresses are different, and whenever we do a comparison like this, the double equal sign is not thinking about the data in the object. It's literally doing a primitive comparison, and the primitive here is memory address. So we're just comparing memory addresses together. So let's see what that means. Let's modify the toString by removing it. So by removing or commenting out this toString method, we know that when Java tries to use the toString method, when it tries to do the display here of Romeo and Juliet, what we should have, instead of seeing the values, it should just display the memory address. So let's see what happens here. Let's compile this guy. Oh, let me just clean this up. I'm going to remove this. Let's compile, perfect. And let's run it. And what we see here is that Romeo is at memory address 1CAC5AF, which I think is the previous memory address it always was, but Juliet is at memory address 12C49AB. So clearly these two addresses here are not the same, and that's actually what the if statement is comparing. When we see if Romeo is equal to Juliet, we're actually saying is the memory address of object Romeo the same as the memory address of object Juliet. It's clearly not the same. So there is no way that we can actually use this idea to compare the two die. So how do we compare the two die together? How do we compare the two face values? Well, we could use this idea. We could ask each object to return back its face value. So in this case, get face value, if we look at the die class again, let's return back the toString method to the useful nature it had before. Get face value returns back an integer. Excellent. And an integer is a type of primitive. So now we're going to be comparing an integer on this side, an integer on this side, and we're going to see if the two integers are equal to each other. And would you look at that? The die are equal because they both have a value of 1 in there. If we try and make a change to it, let's say for Romeo, we will use the mutator and we will set the face value to 3. So now we're going to be comparing 3 and 1 in terms of faces. So let's see, we've got 3 and we've got 1. Clearly the die are not equal to each other. We're using the get face value, and this is a wonderful way of using the accessor to pull out the information. But is there a better way, another way? Well, the get face value method, it seems like a long and tedious way to do it. And what if I just wanted to compare the two die together? I just want to ask the question in a very simple form. I literally just want to say, is this die equal to the other one? And when we saw the string class, we actually saw it this way. We saw the equals method. So when we did a string comparison, we would do something like name dot equals other name. So we would compare two objects together, two strings together. Now, this equals method is something that belongs to the class. So we're going to write an equals method that belongs to the die class. And the way it's going to work is that we're going to give the equals method another die object. So let's take a look at what that looks like. So we're going to do it right at the bottom. Let's just add that right at the bottom. So public, we're going to return back a Boolean because that's the idea. If we go back over here to the die roller example, this whole thing, it better return back a true or false because that's what the if statement expects. The if statement expects, in this context here, that should be either a true or a false. So the equals method had better return back true or false, which means it's going to have to be a Boolean. So we're going to be returning a Boolean. Its method is called equals. And what we're going to pass into it, the parameter for this is going to be another die object. So we're going to have to return back a Boolean. So we'll just call it ret. And let's assume that it's false. So it's always good to assume either false or true, and then let the method figure out if it needs to change that. So now I'm going to return back the ret as well. So just to see if this works, we have this method which returns back. So return true when both die have the same face value. If I could type, otherwise false. Or to use the same syntax as I've done, false, otherwise. So if the two face values are not equal to each other, this is not going to work out. It's going to return back a false, true, otherwise. So let's just compile this, make sure the syntax is right. Everything is working fine. And what we should have is an equals method that works, but it always returns back false. So let's just compile and see if our syntax is right. Perfect, the die are not equal to each other. Now, of course, the die are not equal to each other regardless of what the value is, because we've referred what we call hard-coded that false in there. So even though they're both 1, the die are definitely not equal, because if we go back over here, we're always returning a false. So how now do we check the statement? How do we change the value of ret? So I'm going to have to ask some sort of question. I need to ask some sort of relationship question. So I want to ask that if the face value of the object that I'm looking at, if the object I'm looking at is equal to the face value of the other object, so the face value of the other object. So that's my question. So this is going to look at the face value, which is in this object over here. So whichever object I'm calling, is it equal to the face value of the other object which is getting passed in? So if that is true, then I'm just going to set ret to true. Otherwise, I'm not going to do anything because it will be false and ret is already false. So unless this is equal, that's the only time I'm going to set it to true. Now, let's just pause for a moment and take a look at this. Where is face value and which face value? And there's so many face values here. Which is which? So if we go back over here to the call, we have Romeo.equals. So I'm calling the equals method that belongs to Romeo. So when I look at this over here, when I call the equals method, I'm going to be referring to Romeo's face value. I'm referring to this face value of the object that I'm in, which is also why we can use the syntax this. So this face value, this refers to the object I'm currently referring to. So if we go back over here, it is Romeo. So Romeo is this. When Romeo needs to refer to himself, it's this face value, it's this object. And we're going to compare it to whatever the other object is, the other die object. When we called it, the other die object is Juliet. So is this equal to the other face value? If that is true, then set return to true and return that value. So this is now our primitive comparison. Let's compile it and make sure everybody's happy. Let's go over here. Now in this context, this should be true because both of them are equal to 1 and the die are equal. This is returning back true. So that is a very, very advanced idea of this object-oriented programming methodology. We've got a current object, which would be Romeo, comparing to another object, which is Juliet, and then reaching in and looking at the face value. So this compares the face values of both objects. Now, there's one aspect about this which is interesting. Face value was defined to be private, which means only the object itself. In this case, only Romeo can look at his face value. So how am I able to reach over and look at Juliet's face value without using the get? Well, I don't need to use get face value. I could have written it much like we did up here when we had this statement with if Romeo get face value is equal to Juliet dot get face value. But in this form, how am I permitted to do it? Well, I'm permitted to do it for one reason and one reason only. This is the die class. The die class itself can refer to any of the attributes here. The other rule is that the die class can look at the attribute for any other die object. And if we look at the equals method, the other is another die object. So I can refer to another die object this way. I'm the author of this class. I'm responsible for all the security that is within the class, to the point that there is no security because I'm responsible for it. So I know I'm not going to be doing anything with that face value there. I'm just reaching over and grabbing it. So if we look back over here, now we have a very, very, very powerful little method, which is comparing two die objects together. And I don't have to worry about the get face value and so on. I can just say equals. Now, the other thing I can actually do is I can move the face value from one object to another. So we'll leave it off with just this really quick little fun little method. How can we make two die objects sort of compare against each other? So what we'll do is set the face value here for Romeo. Down below, we're going to use another method here. So we're going to say Juliet um, dot copy Romeo. So we're going to make a copy of Romeo's attributes. Now, he's only got one attribute, but we're just going to make a copy of it. So I'm not doing anything. Essentially, what I'm going to do is this. I'm going to say Juliet set face value of Romeo get face value. So I'm going to pull out Romeo's value for his die, and I'm going to set Juliet's. Now, this is how we would do it right now, using all the existing methods that we have. We've got that the get face value, we've got that accessor, we've got the set face value, we've got that mutator. So I can get Romeo's value, and then I can set Juliet's. So that would work perfectly fine. So just to see how that would work, we are going to make a copy of this statement down below. So what we should see is initially we will see that Romeo has a value of 3, Juliet has her initial value of 1. We make a move of Romeo's 3 over to Juliet, so now they both should have a value of 3, and of course they're both going to be equal. So let's take a look at what I've done here. I've misspelled Juliet's name. Poor Juliet. That's probably why the relationship never worked out. And there we go. So let's compile it. What is the problem now? Romeo. I can never spell Romeo's name. This couple is definitely doomed. So now we see that initially we have Romeo with a value of 3, Juliet with a value of 1, and then we make a copy here. We're using the get face value and set face value. So this would be a long way to get around doing it, but that's using all the existing methods that we have for the die class. But I don't want to use this form. I don't want to use this form. I want to use this form here. I'm going to just say, hey, Juliet, why don't you just get a copy of Romeo's data? Just do it. I don't want to worry about the fact that it's the face value or anything like that. I want to sort of black box this idea. I just want to have Juliet do the copy and take it from Romeo. Exactly what happens, I don't want to worry about it. So, of course, this won't work because there is no method called copy. And just to see that Java tells us that, perfect. There's no method called copy. So let's go ahead and implement it here. We'll do it right down underneath the equals method. So this will be copy um, other die object to this die object. So we're going to reach over and grab another other object's attribute value and make a copy of it locally. So this will be another public. Now this method, if we go back to the die roller, it doesn't return a value. There is no return here. This is going to be a void method. So it's going to be void. It's going to be called copy. And if we look at the syntax one more time, what we're passing into it is another die object. So very similar to the equals method, we're going to call this one other object. So what are we actually doing here? What we're going to do is make a copy of the other one into the local one. So we're going to say that this face value, now in this form, now we're talking about Juliet's. So Juliet is the one that's referred to by this. The copy method belongs to Juliet. So what we're going to do is we're going to make a copy into Juliet. So she's this, but we're going to reach over to other and copy the face value. And that's all we're going to do. We are done. So we've just made a copy of one object into the other one. We're only copying attribute values, and this is the only attribute that matters. So if we go back over here and we compile this guy, and we run it, now we see that Juliet starts off, or Romeo starts off at 3. Juliet starts off at 1. We make the copy. Now Romeo has 3 as he did before, but Juliet has 3 as well. So this is a cool little copy method. Now, it matters which way we're doing it, because what we've really said with this statement is Juliet is assigned Romeo. But we're not just moving memory addresses. This would move a memory address. We're copying the attribute values using the copy method, which is actually pretty funky. So, and the syntax works in either way. So let's say we made a change to Juliet. So let's say Juliet, we set Juliet's face value to 4. So we'll display, actually, you know what we could do? Why don't we just roll Juliet? So Juliet will pick up a random value. And then what we're going to do is we're going to ask Romeo to make a copy of that, make a copy of Juliet's data. So now we should see if they're equal to each other. So let's run this guy here. And there we go. So Romeo at 3, Juliet at 1, that's how we start off with. Then we make a copy of Juliet from Romeo, and then we just decide to roll Juliet, so it changes that. Romeo now has a value of 6 after the copy because Juliet got a value of 6. So we're just messing around with the code here, but the cool thing about all this change is now we also have a copy method. So we have a method that does comparison. We also have a method that does copy. Now, you might also be asking one final thing, why didn't we use the set face value? Well, we could replace this with something like set face value of others get face value. So we could use the proper setters and getters. And really, this is how we should actually be doing it, because this ensures the values are proper. But as the author of the die class, I can do whatever I want because I'm in full control. The security of this class is up to me inside, and I know that the face value is never going to be incorrect, whether it's this object or the other object, because I'm the one setting the values inside. And there's no way out here that I can change the values to be incorrect. I can't set the face value to 30. It's impossible in this program. So we've gone ahead and actually written some pretty funky additional methods, the copy and the equals method. And that's where we're going to leave it here. We're going to continue on with classes. We're going to get some more advanced classes where we're actually having some more methods doing some data manipulation. We're not going to have just one attribute. We're going to have multiple attributes. All right, I'll see you in the next virtual lecture.